welcome to my channel. So in the today's lecture, we are going to discuss another CPU scheduling algorithm, shortest job first. Okay, so as it is clear from its name, shortest job first. Okay, what does it mean? We are giving priority to the processes which are shortest. All of the processes which has less burst time, which has less CPU time, we are giving priorities to all these processes. Okay, why we are discussing this algorithm? In the first come, first serve algorithm, we discussed that we might have a problem of starvation. Okay, we discussed convoy effect in first come, first serve. So before watching this video, you watch my video of first come, first serve. So we had a problem of starvation. What does starvation means? If your process 1 size is very big, okay, what we discussed, we have 3 processes, process 1, process 2, and we have process 3. Let's suppose the burst time of this process 1 is 20, 10. We have 3 processes and we have 3 burst time or CPU time of these 3 processes. What was the starvation problem? Starvation problem was if your process 1 is executing on the CPU, you have allocated your CPU to this process 1, and our first come first serve is non-primitive algorithm. Okay, once you have assigned your CPU to this process 1, you cannot take back CPU from this process 1 unless it completes its execution. Okay, once it's completed its execution of 20 burst time, only then we are taking back CPU from this process 1 and we will be giving to some other process. Okay, so if this process size is very big, its burst time is very large, its CPU time is very large, then these 2 processes has to wait for a long period of time. Okay, these processes are going to wait for a long period of time. The response time of these 2 processes is going to be very large. Okay, they will get response at a very later point of time. Okay, these 2 processes has to wait for a long period of time to get first response from the CPU. If you are clicking on these 2 files, they are not opening. They are not getting executed on CPU. Let's suppose we have a MS Excel and we have Notepad. Okay, these 2 processes are not opening. Even you are clicking on these 2 files when your first process is executing on the CPU. Okay, you are not getting any response from CPU for these 2 processes. Okay, so we have to reduce our response time. We want to execute all the processes of starvation, we decided to make one algorithm of shortest job first. Okay. In shortest job first, you will be executing processes having less CPU time, having less burst time. Like firstly you will be executing process 3, then you will be executing process 2. Why we are doing so? So that we can reduce the waiting time of multiple processes. So that we can reduce the response time of multiple processes. Okay, we try to reduce the starvation problem with shortest job first. If you are using shortest job first, then within a very less time, you are able to execute many number of processes. Okay, if you execute process 1 firstly, it is going to be executed for 20 units of time. If you execute firstly process 3, then process 2, you are executing 2 processes in just 30 units of time. So, with the help of shortest job first, you are increasing your throughput. Within a very less time, you are able to execute many number of processes. Okay. So now, let me tell you how shortest job first works. Okay. Let's suppose we have process ID, we have arrival time, and we have burst time or CPU time. Okay, process IDs are P1, P2, P3 and P4. Their arrival times are 1, 2, 3 and 4. And let's suppose the burst time is 5, 4, 2, 3. Okay, so this is our problem. We have to give this input. Okay, we will be applying this shortest job first algorithm. How it is going to give us output, how much waiting time, how much response time we are getting. Okay, actually your processes are your files like MS Word, MS Excel. Okay, but just to find out the best algorithm, just to find out the efficiency of the algorithm, we are just taking some of the parameters like arrival time, burst time, so that we can find out how well you have designed your algorithm, how well your algorithm is going to give the output. Okay, so now let me make Gantt chart for it. I am going to make Gantt chart for it. Okay, I am starting it from 1. Okay, so initially what we will be doing, your short-term scheduler is going to pick process from the main memory and it is going to give that process to CPU for execution. So initially at 1, we just have only one process P1 present in the main memory. Your process P2 is coming late. It is coming at 2 in the main memory. So in the very starting, we just have only one process present in the main memory. So your short-term scheduler is going to give this process to CPU for execution. Okay, so we are giving this process P1 to CPU. Its burst time is 5 units. It needs 5 units to execute on CPU. Okay, so 1 plus 5, 6. Your process P1 is going to be completely executed on CPU at 6 units of time. Now we are going to terminate our process P1. Okay, so now your CPU is free. Your shortest job first is also a non-primitive. Okay, it is also a non-primitive. It is also not going to ensure multitasking. At a one particular point of time, we are just executing only one process. At a one point of time, you are not executing many number of processes because it is non-preemptive. Okay, so now your CPU is free at 6. Okay, once your process P1 has been completely executed on CPU, now your CPU is free at 6 units of time. Okay, so now at 6 we have P2, P3 and P4 all present in the main memory, like 2, 3, 4. Okay, so all these 3 processes are present in the main memory. Okay, so now your short-term scheduler has to pick one process out of these 3 processes and going to give one process to the CPU. So, which process to pick to give to CPU? Okay, so as we are using the shortest job first, so our short-term scheduler is going to select process P3 for execution. Okay, because its CPU time is very less. We want to reduce our response time. So, we are giving priority to the shortest jobs. Okay, so your short-term scheduler is going to give this process to CPU. Okay, your process P3 needs 2 units of CPU time. Okay, so 6 plus 2, 8. Okay, what is the completion time of process P3? 8. Okay, so now your CPU is completely idle. Okay, we are giving priority to the shortest jobs because we want to reduce the response time and the waiting time of the users. Okay, so now what short-term scheduler do? It is going to select one process out of these 2 processes, P2 and P4. Both these processes are present in the main memory. Okay, so your short-term scheduler is going to pick P4 process and will give it to the CPU because its burst time is less as compared to process P2. Okay, so we are executing process P4. Okay, it arrived in the main memory at 4. Okay, but it was given CPU at 8. It had to wait for 4 units of time. Okay, so when your process P4 is going to complete its execution, 8 plus 3, 11. Okay, it was given CPU at 8. It will execute for 3 units of time and now 9 units before getting executed on CPU. Okay, so 11 plus 4, 15. It is going to complete its execution at 15. Okay, it is going to be terminated at 15. So what is the completion time of process P2? 15. Okay, now let's try to find out the turnaround time. What is the meaning of turnaround time? Turnaround time means how long your process has been alive in the cycle. Okay, let's suppose you have opened MS Excel file. Okay, when you opened it and when you closed your file, the intermediate time between opening and closing the file, we call it as a turnaround time. Okay, so turnaround time is equal to completion time minus arrival time. Okay, your process P1 arrived in the main memory at 1 and it gets out of the cycle. It gets terminated at 6. So, how much is the turnaround time of process P1? 6 minus 1, 5. Okay, it remained alive in the cycle for 5 units of time. Okay, let me make waiting time and response time here. So, what is the waiting time of process P1? Okay, the formula of waiting time is turnaround time minus burst time. Okay, your turnaround time means how long your process remain alive in the cycle, the total time. When you subtract the CPU time from the total time, you will get your waiting time. Okay, so your process P1 arrived at 1 and it was given CPU at 1. So it didn't wait for any time. Okay, as it is arriving, it is given CPU. It is not waiting for any point of time. So what is going to be the waiting time? 0. Okay, 0. It didn't wait any time to get executed on CPU. As it is coming, it is assigning the CPU. Okay, turnaround time minus burst time. So, what is the meaning of response time? Response time means after arriving in the main memory. Okay, after what time it is getting response from the CPU. Okay, once it is arrived in the main memory, after how much time it is getting response from the CPU. Okay, as it is arrived at 1, it was given response by the CPU at 1. Okay, at the same time when it is arriving, it is getting response. Okay, so 1 minus 1, 0. Okay, we don't have any response time. Okay, your process P2 arrival time is 2 and its completion time is 15. Okay, so what is going to be the turnaround time of process P2? 15 minus 2, 13. Okay, if you look at its burst time is just 4 units. Okay, so 9 units it was waiting for the CPU. Okay, you are giving it CPU at 11 and it arrived in the main memory at 2. Okay, it had to wait for 9 units of what is going to be the completion time? 30. Waiting time is 9 plus the burst time 4. Okay. So this way we are calculating the turnaround time. And what is the waiting time? Waiting time we have is 9. It is arriving in the main memory at 2 and it is assigning CPU at 11. It had to wait for 9 units of time. Okay, and you can also subtract turnaround time minus burst time to find out the waiting time. And what is the response time of process P2? Okay, so if you look at your process P2 is arriving in the main memory at 2 and it was given first time response at 11. Okay, so after its arrival, how long it waited to get the first response time from the CPU? Okay, it was given response at 9 units of time after its arrival. So, response time is going to be 9. Your process P3 arrived at 3. Okay, it arrived at 3 units of time and it was given CPU at 6 units of time. Okay, it arrived at 3 units. It was given CPU at 6 units. So what is the waiting time we have in this case? The waiting time is 3. Okay, so and it executed on CPU for 2 units. So how long it has been alive in the cycle? What is the waiting time? 3 units plus burst time 2. 5 units of time. If you subtract completion time minus arrival time, it is going to be 5. And what is your waiting time? Okay, it arrived in the cycle at 3 and it was given CPU at 6. So it had to wait for 3 units of time before getting the CPU. Okay, so 3. How you can calculate the waiting time? The total time of the cycle minus CPU time. You will be getting your waiting time. And what is the response time? Your process P3 is arriving in the main memory at 3 and it was given response by the CPU at 6. So after its arrival, how long it waited to get the first response time from CPU? 3 units. Okay, 6 minus 3, 3 units. both is waiting time and response time equal. Why it is so? Because this shortest job first is non-preemptive. Okay, once you have allocated the CPU, you cannot take back CPU from that process unless that process completely execute. Okay, if your algorithm is non-preemptive, in that case our waiting time and response time is going to be equal. Okay, because if you are using preemption, okay, if you are using preemption, then you will be giving CPU to one process many number of times. Once you have assigned your CPU to process 1, okay, then after some execution of its instruction, you will be switching your CPU to another process. Okay, and at a later point of time, you will again give it back to this process P1. Okay, so all of that time when you are giving CPU to processes and how long your processes are waiting for the CPU, you will all count in your waiting time. Okay, but your response time is just the first response time from the CPU. Okay, when you switch your CPU from process 1 to process P2, again your process is going to wait for CPU. In this non-preemption, your process is just going to wait for CPU only once. It is not going to again and again wait for the CPU. But if you are using the preemption in your algorithm, then your one process is going to wait for CPU many number of times. Okay, so in that case, we take different waiting time and response time. As it is a non-preemptive algorithm, we are taking same waiting time and response time. So I hope that you are clear with this example. If you have any query, I have mentioned my email ID in the description box. If you like my video, please like, share and subscribe my channel.